Okay, so welcome to day 2 of the computer science workshops here at ATU Donegal. Following on from yesterday, this is the schedule for today. So this morning, what we're going to go through is the SDLC, Software Development Lifecycle. Then you'll have a break from 11 to 11:15. Then we come back from the break, we're going to do another Section C. So we did a Section C last year, looking at last year's exam yesterday. Today we're going to look at the mock last year, which is going to be slightly different. It's going to be reading in data from a file. So that can come up, you need to read in information. So we'll look at that and how to do that. Then that'll take an hour, 12:15 to 1 o'clock, you'll have lunch. And then for the last hour, we're going to look at electronics and the CPU. Again, all the topics I've tried to do today is stuff that is relevant to come up in the exam. There'll be a lot of exam questions that you usually have to work through and then feedback to myself. And we'll look at the marking scheme and what they're actually looking for to get you the optimal marks coming up in your exam. So just before we get started, a little bit about myself. My name's Owen Gallen. I'm a secondary school teacher in St. Eunan's. I teach computer science. Teaching it now for 4 years since the first year it came out. And that's all about me, and just hopefully today will be useful for you. So there's a QR code that has all the PowerPoints of all the information that we are going to cover today. If you want to scan that now, I'll show it again at the end of the day, but just so you have the information. If you take it should shared my Google Drive with you, and it has all the content of today in that QR code. Okay, so we'll get started. So what we're looking at today is the SDLC in this morning's session. It's kind of how we design and develop software. It's a very important process, and it's a process you're probably all well familiar with now from after completing your project. You are actually doing the SDLC in creating your Lebensjahr project, but you probably don't realize it, but you're doing all the steps involved, the investigation, the plan, the design, then actually going off coding your project, and then come back and evaluate what you improve, what areas would you change, stuff like that, okay? And like I said, this comes up, came up every year in the Lebensjahr, okay? So it's a very important topic. So, learning intentions, look at the advantages and disadvantages of the different SDLC models. So there's 2 models in particular we look at. One is Waterfall, the other is Agile. And then how they're applied in real world software projects. So up to now, when you're using the SDLC, you've been thinking about a small project, your Lebensjahr project. We need to look at it now when you're answering your exams. You're looking at like big projects in the real world, like Microsoft to be using, or Facebook, or these big companies. Second, learning intentions, distinguish the different roles in the SDLC. So there's different roles in this methodology of people from developers to coders to designers to people who's managing the money, business analysts. No, we need to know all of them roles, okay? Then the last one is understanding the principles of Waterfall and Agile, okay? So what does both of them 2 terms mean, okay? This year's project didn't ask you to understand Waterfall and Agile, but in the past 3 projects for Lebensjahr Computer Science, you had to know the 2 methodologies. So you probably aren't as familiar with them words, Waterfall and Agile, and what they mean. So we need to understand both of them terms. Okay? So have you any heard of the software development lifecycle before? You've covered it? Yeah, some of you have, some of you are shaking your head saying no. Okay? So the software development lifecycle is a process where you're producing software, okay, to the highest quality and the lowest cost in the shortest time possible. So what companies do, the likes of Facebook or Instagram, the Microsoft, all these, CETA, Primerica, when they go off to just develop software, you just don't sit down and start coding, okay? That doesn't happen. It's a whole process involved in this where there's two methodologies behind it. There's a short-term one that's kind of quick cycles, and then there's a big long-term one, and they're used in different, for different kind of types of software you're going to develop, okay? So the SDLC provides a well-structured flow of phases that help an organization to quickly produce high-quality software which is well-tested and ready for production use, okay? So it's a process that is used by nearly every company when they're going off to develop the software, and this is why you do it in your project. You just don't sit down and start coding, okay? You have to go off and investigate, find out what you're building, make a plan, then you have to go off and design it, find out flowcharts, how the data moves, maybe system architecture, all the different stuff, okay? And then you finally then start coding. So when you know exactly what you're going to do, you then start to code. And it's no different, the process in the business world, okay, in real world projects. So the SDLC, these are the phases, okay? You plan, you make a plan of your action, so what you're going to do. Then you go off and requirement analyze, so you can find out what are you building, okay? So this requirement analysis can be in-house, so it could be like Primerica up the road in Letterkenny here, or Microsoft. They could be building software, like building onto Microsoft Word, or you could be building software for someone outside the business. So you could be developing for a sports shop, or I don't know, basically a makeup company or something that has no software skills. So you could be doing it in-house for someone who knows what they're doing, or you could be doing it for someone who does no idea of any coding skills or stuff. So your requirements for that there, you have to find out what are you building and why are you building. Then you go off then design, okay? So in your project for Leavenscert, you did your design, you did flowcharts, system architecture, you could have wireframes in there, basically showing what it might look like, the website you're going to build or the program. Then you go off and develop it, so that's coding it, okay? When you finish coding it, then you test everything to make sure it's working the way it should do. So you'll be testing it when you're building it, but then at the very end you have like your own tests of making sure the whole system works the way it does it save the data where it's meant to, all that kind of stuff. And then when you finish your test, then you go off and deploy it so people can go use it. And after you deploy it, then you're basically maintaining it. So if there's, like, think your PS5, many updates and stuff it requires. So it's just constantly maintaining it, giving it updates that if there's a bug or an issue that comes up that you didn't realize, that you fix that, okay? And in this stage 2, you'll have a pile of documentation of how you built it. So if anyone ever needs to come in the future and take up if someone leaves their post who built up the part of it, that they can come in, someone else come in and basically understand exactly what they have to do if they have to fix a bug, okay? So you need to have piles of documentation on what you've built, okay? So again, these words will change when you're looking even online, if you're Googling the SDLC. Sometimes this will say investigation, requirements, it's all kind of an overlap, okay? So again, requirements gathering, so gather what they want, make a design of how the system is going to be built, go off and code it, write the code, and then make testing, so you have to test that everything works, deploy it, and then maintain it, okay? There are the steps of the SDLC. So there's two approaches of using these steps, okay? There's a staged approach, which is going from step to step, and you can only go from requirement. When you finish it, you go here to design, you completely do design, and then you go to development. That's called a staged approach, okay? So you do each in a linear sequence, so you can't jump from stage to stage. And this is done called a waterfall, and we'll look at a waterfall in a minute. But basically, you're going from one step to another. There's another approach called iterative, And the iterative design basically allows you to jump back. So if you're in here in requirement and you go to design and you go to development and you realize something, you've missed something, and to iterate, you can go back up here and make the changes. Okay? It's very important to know them two. Often in your exam, it'll ask what's the difference between a staged SDLC compared to an iterative. Okay? And there's other words to them as well that we'll look at in a minute. So I know I showed you these two, the planning, requirement gathering, but usually in Leaving Cert Computer Science, when this comes up in the exam, it's this. Investigates your first stage. So this is what you would have did in your project. Then you go into plan, then you have a design, you go off and code it, create, you evaluate what you did. So you evaluate what went well, what you improve, and then you make documentation. And then you see this iterate. If you have a problem in evaluate or create, you iterate back to where that problem occurred, fix that problem, and then go through the steps again. So iteration in the SDLC is very important. Run into a problem, see how you can fix it. So wherever that problem came, so you can maybe need to go back to investigate and do your reinvestigation all over to fix that problem that might have come up in design. Okay? Iteration is a very important part, and it asks, definitely in 2 of the past exams, it's asked about what is an iteration. Okay? So it's very important you know what to iterate is. So the first methodology we're going to look at on this is called the Waterfall methodology. Okay? And it's linked to staged. So it's one of the staged. So if you think back, what did I say the stage was? Do you remember? Yeah, linear sequence. So it's going from step to step to step. Okay? You can't skip steps. So again, this waterfall, find out the requirements, design, implementation, verification, maintenance. Different words than before, but it's doing the same steps. Okay? So for a waterfall methodology, you find out completely what you're going to build at the start. That could take, in waterfall process is usually 18 months to 48 months. It's a really long process to do it in waterfall. Okay? So requirements might take 3 to 6 months. Who are you going to get the requirements of? Yeah, the user, who you're building it for. So you're going to have meetings with maybe the head of another CEO. You're going to go to them and go, what do you want me to build? You're going to have surveys with their staff. So say if we were building a system for Lidl or Aldi, you'll go to and you're building a checkout system. You'll go into their staff who's working at checkout, you'll give them surveys. What's working well, what would be good for this idea of the system we're going to implement, okay? So that there takes 3 to 6 months. You're going to the user and ask them what they want. After you do that then, you go off and make a plan also in this, plan of action. Requirements as well, sorry, before I move on. A big part of requirement is for these big projects is budget. Do you have enough money? And time, okay? Because it could take 15 months, it could take 24 months to build. Often these are delayed to waterfall. Do they have enough time to wait that? And maybe it could be 500,000 to build. Do they have enough money and time? Because when you go in to implement, to build the software developers aren't cheap, okay? So it is a costly expense. So after you get all your requirements and work out, is it possible to do, is it feasible? You go off then and design. So flow charts, maybe wireframes, which are cheap, kind of visual representations of a website to show back to the user and give them feedback. Is this what you want? Do you want me to go off and build this? Okay. When then you get your design done, you hand over your design documents to your programmers. The programmers start to code. Okay. Now, in design and requirements, you'll need to work out what languages are we programming in. So not everything's done in web design or HTML. It's JavaScript. Is it Python? Is it C#? Okay. So it could ask an implementation in your exam. What is implementation? Okay. It is coding the software, but it's also having the right people in the right areas to code in the different languages. Okay, so you'll have, when you go off to college next year and you do computers, there's not just Python and JavaScript, there's C#, there is Ruby, there's PHP, there's all these different languages, so you need someone in the right areas to code your website. Okay? After then they've did all the building the software, they go off and verification, which is testing. Okay? So testing is a very important role because you need to test it works. Okay? There's different types of testing. Okay? There's unit testing, which is kind of done when you're building it. Does anyone know what unit testing is? Anyone? No. So unit testing is, you know, in your programs you have functions. So you do kind of little parts, chunks of code at a time. Your unit testing is them little chunks of code. You're testing them as you're going along. And that's also called white box testing. So white box testing is testing the program as you're going along. Okay? There's another type of testing called black box testing, which some of you probably did in your project and didn't even realize. It's where you've developed the project and you give it to someone basically to test who's never used it before and see what they do with it. Because they'll use it in a way you've never thought the project was going to be used in, the software. So say if I built a project to add numbers, say 5 plus 5, that input 2 numbers and I give that to my friend, he might put in the word 5 instead of the number 5. Does that break my program? Okay, so it's really important, black box testing, you give it to people who's never seen it before, and they might use it to break it, use the program in a way that it was never meant to be used. There's other ones there too, there's called system testing. So system testing, testing the whole system from top to bottom, that everything works the way it should. Okay, and then there's another one called acceptance testing that sometimes comes up there, that if they put in an invalid error, does that show back to the user that they put in something wrong? Okay. So last thing then, in the waterfall, is you go off and maintain it. So you have all this so all these stages are documented the whole time, and then you have a pile of documents and maintenance if ever needs to fix something, maybe in some of the code slightly wrong, creates a bug. Then you go off to your documents, you flick through your documents and go, oh, that's how you did that, this is how I fixed it. Okay? If you run into a problem in implementation, say here this is about 6 months, this is about another 6 months, this will take probably 12 months. Okay? But if you run into a problem here when you're coding and you realize, oh, I actually can't do one of the requirements, what actually happens is you basically have to kind of nearly scrap the project. You have to come back and go right up here and just redo this, and then you have to redo this, and you have to redo this. That is why they spend so long in each stage, to make sure it's perfect so that they don't run into problems further down the line. Does that make sense? So roughly how long would a waterfall methodology take for a company to build a project? Yeah, 18 plus months, okay, usually. Okay, so it is a long process, but it's really well thought out, and you get good quality software at the end, so nothing should go wrong. So there, just again going through what I'd said, it's distinct phases, each of which must be completed before moving on to the next. So if you're doing requirement, you can't start designing until you have requirement finished. Okay, it's a highly structured approach that provides a clear framework for the development of the software. And it's ideal for projects that have really specific requirements. Okay, I would normally say waterfall is kind of like for life systems. So something that cannot go wrong. So something like autopilot in a plane. You wouldn't want autopilot to go wrong, would you, in a plane? So stuff like that. Life machines require software in hospitals. So life machines, you don't want that to go wrong. You don't want the software to fail. Because if you think that process of everything being correct, spend 6 months, 12 months, everything needs to be really well thought out for the software of Waterfall. Okay, so there's each stage. I've kind of gone through it. Requirements, gather your requirements. Is it possible to do? Do you have enough time and money? Design it. Okay, so system architecture, flow charts, all the design, wireframes, maybe showing them a small prototype there. Implement it, go off and code the project and whatever software is required. Then test it, system testing, unit testing, making sure everything works the way it should. Deploy it, so go off and release it, okay? And maintain it then in the future. Okay, so there are the steps of Waterfall. Now, there is iteration in Waterfall, okay? So basically, if we run into a problem, we iterate back to the last stage. That basically, can we fix that problem that we run into? Can we go back a step? And then can we fix that problem, okay? So something like this here, so see here where you're going back. So if you run into a problem in design, can you go back to the requirement and overcome that problem? So iteration is run into a problem, go back a step, and can you fix that problem? Okay? Now, if you run into a problem in design, you can only go back one step, or if you're doing it in implementing it to full software, you can go back to design. If you can't fix that in design, you basically have to go back the whole way to the start and just basically restart your project. So that's why you spend so long, 6 months is a long time, that's why you spend so long in each phase to make sure everything is perfectly lined out the way it should be. Does that make sense? Okay. This iteration does come up a lot in your exam. So what does it mean to iterate in the software development project? Run into a problem, you go back to the last stage, and can you rectify that problem in the last step? Okay? Those come up quite a bit. So, in designing software, you're not, well, you did, when you were doing your projects, you did it yourself, okay? But this is the reason why we do you know the ALTs, the 4 applied learning tasks? Okay, I know we probably did not do all 4 in your 2 years, but when you're doing your ALTs, you're meant to do them in teams, okay? The reason you do it in teams is when you go off to work in the real world, you're not there coding by yourself. You're in a team of 4, you might be in a team of 10. If you're working in a big mass company, you could be in a team of 200 people, all working on the one project. So this is this idea of collaboration when designing software, okay? So in Waterfall, there is kind of 4 main roles in the project. Obviously, you're going to have a developer, okay? The developers is probably the most important role because they're actually doing the coding, okay? They're building it. You can have 1 developer, you could have 10 developers, you could have 200 developers, okay? You could have 4 developers working on Python, you could have 10 developers working on the HTML, JavaScript. So the developer is probably the most important. Then you also have a team of testers who basically, when the development's done, they'll hand it off to the tester. And the tester basically, what are you trying to do as a tester, do you think? Find any errors about. What are you saying, when they hand you the code, what are you also trying to do? They're basically trying to break the code. They're just trying to break it. So if they break it, they just come back and go, developer, I broke X, Y, and Z. You need to fix that. And then he'll give it back to him and say, I fixed that, can you break that again? And he'll go off and try and break it again. So you're just basically a tester trying to break the code, okay? They're trying to put in stuff in areas that might cause the program to crash out or something. Okay, so they're kind of 2, the developer and the tester kind of working in tandem with each other. I'll show you a diagram of it in a minute. Then this person's also quite an important person here, a business analyst. Okay, so the business analyst is responsible for making the software product popular in the digital market. Okay, so he's basically writing strategies of how to sell this product at the end. Okay. Maybe marketing it for people to come in and use it. They need to be involved in the kind of process of the development too. They'll have a say in what is being done in the project. Okay. Then the project manager is kind of like a manager of anything. He's the boss. So he is in charge of the thing. So if it goes wrong, if a project fails, the developer, the tester, stuff like that, usually don't lose his job. It's this guy. Okay? So what he does is he makes sure everyone's doing their job. He also makes sure everything's on time. And what's the other big thing he'd need to make sure? So everyone's doing their job, it's on time, and it's within budget. Okay? Because if it goes over budget, then it's his fault. And often these things do go over budget. So he's just making sure everyone's working in tandem. We have the timings correct, and then we're within budget. And he's in contact with who we're developing for. So he'll be giving back them feedback of what we've did, and is this the way you want it and stuff. Okay? So that's what we have. The project manager, you have business analysts who's telling them the requirements, and then you have the developers and the testers. Basically, developers coding it, the testers trying to break it. And you may have, it's not really that popular, but you may have a test team manager too, so they're all working in the one way as well as the developers. So the developers would be over, the project manager would be over the developers and the testers. Okay? But the developers, they get the requirements that's set out at the start, and they're basically trying to achieve them requirements. So whatever them requirements are. Every project is different requirements. Okay? There isn't projects with the same requirements. So that was the waterfall. There is other stage methodologies. There's spiral, which is going in a spiral. There's throwaway prototypes, so where they build a prototype first, then throw it away. And then there's just prototypes. You build a prototype of a project, so like a website or something, just with no functionality. You give it to the user and go, is this okay? And they'll say yes or no. And then you throw that away and go off and build your other project. There are other stage design. There's not just waterfall is the most common and the one that's always asked on your exam, but there is other stage designs as well. But waterfall is the most often. So, first question for you is, state 2 tasks that would be undertaken by a project manager in a software design process. Okay, so we looked at the project manager and what they did. 2 things, I'll give you 2 minutes, 2 things that they would do, and then we'll look, this came up in last year's exam. Okay? So as it's question 10, that's a short question. I would say it's a mark for this point and a mark for that point, but I'll double check that in the marking scheme. But because it's question 10, it's a short question. So state 2 tasks that would be undertaken by a project manager in the software design process. So remember, it's in the software design process. So again, it gives you 3 lines per point. So if you can, try and fill them. Try not just to write there, like take control of the team, because you're only going to use to about there. Try and bulk out your answer in English. When an examiner who's marking the exam sees a lot of writing, even though sometimes it might be gibberish, it looks like you've written a better answer. So do fill it out, okay? Don't try and give 1-word answers. Give you another 30 seconds and then we'll just go through the marking scheme. right? So we'll just go through the answers here, and I've just took this from the marketing scheme, okay? So it asks, state 2 tasks that would be undertaken by a project manager in a software design process. Okay, so the manager, what is the manager in charge of a project? Agree requirements with the customer, so they're in contact with the customer of what the customer wants, okay, which is pretty obvious because they're in charge. To ensure the system project is delivered on time within budget. So any of these you get 1 mark, so you need 2 of these. Any 2 of these you get the marks. Oversee the project schedule, planning, setting key dates, milestones. Resource the project, so everyone who's staff, who's money, who's over money and stuff like that, he's doing all the resources for it. To assign tasks related to design, so giving the tasks out to the correct people. So is the UI designer getting the design in it, the certain Python developers getting the coding of it. Okay, so he's giving the tasks to each people. Communicate and motivate the team to basically develop the project. Okay, so he's a motivator and keeping everyone on task. To monitor the progress and any other relevant points. Okay, so that is the project manager. And again, said each mark, each one of them you put in was 1 mark each. So you got 2 marks for that. That was one of the short questions. Yes? There is, so that was part A. There's a part B that was related to something else that got 3 marks. Okay? Anyone any questions on that? Does that all make sense? So from what we've did, the waterfall process, where do you think what would be developed in waterfall? Does anyone have any ideas? In the real world, where would you use a waterfall for developing anything? Yeah, something like inside the plane, like your trackers and stuff like that. Yeah, because it's important that that's something that doesn't fail. Okay, so I'll show you some waterfall project examples. Government projects. Okay, why would a government? Care to think? Why would a government something like revenue? So revenues where you get your pay slips and your how much money you get paid, tax and stuff like that. Why would that be important to be developed in waterfall?
Make sure it's like safe and secure.
Exactly, safe and secure. So nobody can access the information that if someone hacks that there, all the details of basically everyone in this country who's getting paid with pay slips is out and is available to people. So it's very important something like that there is done securely. Okay. Another one's banking systems. Okay, banking systems. You can't have people hacking into banks. Money will be taken out. Okay. Resource planners is planning resource of making sure people are in the correct place at the right time. So they're actually done using waterfall as well. And then large scale enterprise systems, so HR systems, which is like looking at human resources. If anyone's in trouble or anything, they might open a ticket on the HR system. So that other people can't see that information. Okay, it's making sure all the information is secure. And then a supply chain management system, so goods being supplied to places, so stuff like weather and supply and stuff like that there, that is being taken into detail, that the supply of goods is reaching the correct place, okay? But the main kind of ones is any kind of life system, so likes of your airplane systems or life machines or the government, something that needs to be secure and can't be, you don't want that information compromised, okay? So that was the first methodology, waterfall. The second methodology now we're looking at is this thing called Agile, okay? So you think the word Agile, it means quick and you can move and stuff, even just English word. This is similar. So this is like a process that's quick to design software. It's flexible. You can make changes and stuff, but it still follows the same steps as waterfall, but it's done in a lot quicker sequence, okay? So you still make your plan, your design, you develop, test, release, feedback, but it's an ongoing cycle that is happening in the process. So the Agile is iterative. It's an incremental approach that focuses on delivering software in short bursts, okay? So it's working to deliver software in short bursts, okay? And the emphasis of this is in collaboration between the colleagues. The customer is a big part of this, so the customer's telling you what do they want and when, and then continuous improvement. So you might build a little thing. So the way I look at it, like Snapchat, okay? So if you take the example of Snapchat, when Snapchat first came out, what was Snapchat? You maybe too young. Snapchat was just an image. So you just took your image and you could send it to your friends, okay? The next iteration of Snapchat was stories. So you had your image, you could send your image, then they brought in stories, okay? After stories then, there was snap maps, okay? So you can see where people is. Then after the snap maps, there's another iteration where they brought in messages. So it used to be only photos, now it's messages as well. Then another iteration of now where you can go on and see influencers' stories. So it's not just your friends' stories, it's influencers. So it's an iterative process where they've built something to begin with, and then they keep adding to it. So that's what Agile is. You're constantly asking the customer what do they want, and you're constantly adding to that. Now, in some aspects, some people put Waterfall and Agile together for developing some software. We might have Waterfall at the start, so something like the PS5 would be Waterfall, but then it would take an Agile approach as well to continuously update and maintain the software, okay? So Agile methodology is highly flexible, collaborative approach to software development that emphasizes customer feedback. So you're always asking the customer, what's the next thing you want? What do you want improved? What do you not like? Can we fix something? And it's doing these steps of finding out that it's little sprints, so it's about 4 to 6 weeks. Every 4 to 6 weeks, you're making an improvement for the customer. Now, Waterfall is kind of, it's still used, but it's kind of, about 5 years ago, a lot of companies are now using this Agile approach. Okay, so it's what is being used now in industry. If you go off, do your degree, you'll be using this Agile when you go out to work with your Googles, your Facebooks, Meta, any of them. Okay, so again, it's kind of the same steps. You get the requirements, so shorter requirements. So what do the user want? The customer. What does the customer want? And that be added into this thing called the backlog of user stories. So this user stories is everything the user wants put in. So then you have a sprint of 1 to 4 weeks. So a sprint's a short period of time that allows you to try and implement one of these features that's in the backlog, okay? Again, you go off and try and develop one of these features, short, sharp features, something small, and then again you go off then and test to make sure everything's correct, because you obviously don't want to release something that may have bugs. So testing and development's kind of the same process where you test the feature you've made, does it work the way it should, okay? So then at the end of that there, then you review it. Did you get what they wanted? You have, this is a big one, stakeholders, comes up a good bit. So you get feedback from the people you're building it for, their users. What is it that they want? Did the thing you implemented maybe the last time, was that any good? Maybe we need to take that out, okay? And their feedback is basically planning what you're going to do in your next sprint. So the likes of Snapchat, when they implemented stories, they would have went and asked some of their users, some of the people within the business, whoever's used the project, did you like that feature? That's why sometimes you get a pop-up saying feedback, and they're basically looking for their feedback, okay? Before your time, Facebook, now you have Messenger and Facebook. Facebook used to have a big bar down here at the bottom right corner. It said chat, and you click that, and all the people would come up that you chatted to. They removed that about probably 7 years ago now, 6 years ago, and there was massive complaints. There was a lot of people said they'd never use Facebook again. It was because it was such a change in the UI, people weren't used to it. So if they were taking in the feedback, they wouldn't have did away with that, but they seen further down the line that people would be using Messenger to ring people and contact on phones and stuff like that and live chat. So they seen by removing that in the desktop, they seen the switch that everyone was changing to mobile, okay? So sometimes your feedback won't be actually taken on. So then after you get a review and feedback, you deploy it, okay? Deploy the new feature, and then again, you maintain that feature. So even though you're constantly adding every 1 to 4 weeks a new part to your system, you still need to maintain that in case a bug may come up. as updates and stuff like that of software that may happen that you need to maintain it. Again, iteration is very, very important in Agile. It's basically used to enable the development team to deliver a quality product that meets the customer's needs. Okay, so you can see here, if you run into a problem, you can go back and make a change to that problem. Iteration in Agile is a lot more flexible, so you have these steps. If you run into a problem when you're testing, you can go back up here to design and make changes. It's not as rigid as Waterfall. So Waterfall is said it's about 18 months to 48 months to develop something. Agile, you're developing something every 1 to 4 weeks. So it's a really fluid process, and that's why it's called Agile, okay? So iteration, you can make changes, and you will make changes a good bit in Agile. You're constantly, because you're getting customer feedback. If the customer doesn't like something that you've implemented, you're just going to remove it, okay? So again, Agile, there's roles in Agile. Kind of like the roles in Waterfall, they slightly differ. So you have a team lead, and he's called a Scrum Master. So in the Agile methodology, what they do if you're working in an Agile team is every morning you come in, you have a thing called a Scrum meeting, okay? So what happens is you sit around in a room, and you'll have your team lead, you'll have your developers, you'll have your testers. Everyone stands up and they basically answer 2 questions. What did you do yesterday? What did you not get working? And what are you going to do today? Okay? It's all to do with productivity to make sure everyone produce better stuff. So they tell them what they did yesterday, talk to the team lead, what are you going to do today? Or what any problems you run into and what you're going to do today. Every morning the person stands up, everyone goes around the room and does that. It takes about half an hour. So then that's called a Scrum meeting. Then you have all the team members, so the developers, the programmers, and the testers. They're the team members in Agile. This person here is very important, product owner. So the product owner is the person who owns the product, but they're really important in the process. So in Waterfall, the person who owns the product you're designing for is only involved in the requirement stage. So they'll find out what you want. You'll get the requirements of the system, and then they don't see the system in Waterfall until it's down here, until it's actually finished. So that could be 24 months without any kind of contact with the person you're developing for. In the product owner here, they're constantly involved. So you're asking them every 2-3 weeks, what do you want next? What do you want involved next? What do you want me to develop for you? And they're giving you feedback of telling you, oh, this works well, this doesn't work, can you change this? Okay, it's constant feedback. And again, the product owner has active stakeholders. So people like the users, the developers themselves, the testers, even the project manager of who and what they're looking for, okay, and what they think of the product. So here's stakeholders. Stakeholder refers to any individual or group that has an interest in the project, okay? So they'll be telling you what's good, what's bad. They're kind of feeding back to the product owner, and then the product owner is telling the team lead what do they want improved next. Does that make sense? Yeah? So again, this is kind of your product owner. They have a list of everything they want in their project. So they'll have a list of everything they want in the project. That is then given to the team. So what do they want to do? And then they do a sprint of every 1 to 4 weeks of trying to maybe develop point 1. Then after 4 weeks, develop point 2. That might take 2 weeks. Then after that 2 weeks, they want to develop point 3. And they're basically giving back to the product. He might go, well, point 1, I like that, but could you add this? So that will go down there to point 4, then he'll add in another thing. You're working through this backlog that in sprints of 1 to 4 weeks, you're trying to do it. And again, you have your daily meetings with your Scrum Master, who's basically the project manager, who's making sure everyone's doing what they're meant to do and on time and on task. But they're basically it's more adaptive and agile. And then you're just, every 1 to 4 weeks, you're trying to develop something. Does that make sense, Agile? Yeah? Okay. So, again, like the last one, where you're project manager, this is a exam question from last year's. It was one of the long questions. It's about a small dog boarding business whose aim is to meet the needs of dog owners who often have a difficulty in finding a safe and reliable place to leave their pets. Their owners, John and Mary, have worked tirelessly to grow the business, and in addition to boarding, it now offers a range of other services including grooming, massage and training. So I've mentioned to you, sorry that came out, I mentioned to you about the stakeholders and their respective roles. Okay, so can you name 2 stakeholders and what role they play in the project? So stakeholders are a thing in Agile. So who are the stakeholders in the Agile methodology, and what role would they have in their dog business? Okay, again, another kind of 2-3 minutes to do that, and then again I'll go through the marking scheme answer. Okay, so remember, stakeholders is anyone involved in the process. Again, that's a long question. I think that was worth 6 marks, so 3 marks for each point, for each stakeholder and role. Just give you another 30 seconds, go through the answers. So, first stakeholder in the project for the dog kennels system. What'd you say?
The owners.
The owners. What's the owner's role?
They're the ones who are taking care of the businesses who are doing all the...
Yeah, the owners, they're basically taking care of the system, okay, care of the business. Another stakeholder?
Developer.
Who?
Developer.
Yeah, the project developer. Okay, so the software developer, what's their role?
You're responsible for creating the website or the
Yeah.
business.
For building the system. So there's your stakeholders, okay? So you have the dog owners, the general public, and the customers. So actually the people that own it, they're going to be the end user. So they're going to actually use the system. That's their role. Your other stakeholders is your people, the KN9 kennels, John and Mary, who own it, and their employees. They're going to be basically users of the system and people who fund it, who's going to be building it. Okay? And then the last person, stakeholders, anyone who's working on it. Okay? So you can see there any relevant description. So project manager overseeing it, the developer programming it, the designer making the UI design of the system, whatever. Okay? And you can see there 6 marks. So I would probably 1 mark or 2 marks for your stakeholder and 1 mark for their role for each. Does that make sense? So to understand what the stakeholder is in the Agile is really, really important. So another question. Explain why the choice of software development process is important when it comes to designing and developing systems, software systems. Okay, so we've looked at the 2 methodologies, Agile and Waterfall. Why is that important when you're going off to develop software? So that came up in, I think, the exam 2 years ago. Why is it, no, that was the same question as that one, the dog kennels. That was part 4 of that question. It was in last year's exam. Why is it important that you choose a methodology or so when designing software? Okay, so give you a minute or two to answer that. That question there is 3 marks out of a long question. So another minute, and we'll go through the answer. Right, so explain why the choice of software development process is important when it comes to design and developing software systems. So it doesn't actually mention any Agile or Waterfall, just asks the software development process. So the choice of the software development process and methodology, which includes Waterfall or Agile, is important. It enables a project to provide better estimates, deliver better software, stable systems, keep the customer informed, create a clear understanding of the task ahead, which Agile and Waterfall both do, and identify pitfalls earlier, allowing for ample time to make adjustments. Okay? So if you just mention the key aspects of Waterfall or Agile in there, you're going to get your marks, because that's what both Agile and Waterfall are trying to do, them SDLC processes. Okay? So provide better estimates for time and cost, delivering better systems because they're more thought out in both processes. You're thinking out what you're doing, and you're getting a good understanding of what you want to build. And then by doing that, you'll identify any potential problems and then you can make adjustments to them problems. Does that make sense? Again, that was 3 marks, and that's just directly from the marking scheme. So that kind of covers the Agile. Like Waterfall, like the first staged one, this is iterative methodology. There is different types. You have Lean, you have Kanban, extreme programming, but the main one you need to know for computer science at Leaving Cert is just Agile, okay? But there is different versions of it. So benefits of Agile: decreased time to market, higher investment recoup, increased productivity because you're getting people to short sprints, so it's more kind of fun for them. You have higher control because you don't have a system requirements at the start. You can't change or deviate from that because 24 months is a long time in Waterfall. The world can change, software and products can change. Enhanced client experience because you're getting constant changes. Transparency, ongoing engagement between the customer and Agile, so you're always in contact with the customer and the people that owns it. Simplified altercations, easier forecasting, and perfect quality. Okay, better quality product. And as I said, all kind of companies now are going with this. Okay, so there's your kind of differences. Stage kind of process, you just go from the top right through iteratively to the bottom. Where this is an ongoing process, you're just constantly, that's why it's in a loop. You're constantly, every 1 to 4 weeks, you're just developing something. So projects are implemented faster and they go live sooner. But if you run into a problem here, like you mightn't have a better quality system because this is really, really well thought out, okay? But it's a lot slower and dear. So again, Agile versus Waterfall. Waterfall's long-term, Agile's kind of short bursts. The distance between the customer and developer. So the customer in Waterfall is found out in its requirements and they don't really get seen again until the product is finished, where the distance in Agile is they're in constant communication. Okay, that's the thing about Agile. Again, time to discover problems, and this is long because you might do requirements in your design, that could take 12 months, and then when you're coding something, you might realize you have a problem, so that's 12 months, where in Agile, that could take 2 weeks into the process, because you'll be coding after about 2 weeks. Again, project schedule risk, very high in Waterfall, because if you have one problem at the start, you can't fix that, okay? If you're down testing and you work out you have a problem, that could be 24 months down the line, you could have to scrap the project, where this is short bursts, okay? And then ability to respond quickly to change. You can't respond to change in Waterfall, because if you started here and you're down, again, 18 months down the line, you can't change to what you were required to do at the start, where Agile is a constantly changing approach, okay? You're adapting to stuff. So again, I know kind of nearly at 11 o'clock, but there's another exam question. I'll get you to do it. But this one, just to show you, it asks, state whether you would choose staged or iterative development process for the project. So when it asks for staged or iterative, staged is your Waterfall, iterative is your Agile. Does that make sense? Okay. So again, any suitable demonstration of understanding. Staged approach, simplicity and clarity. Long process, you know exactly what you're going to do. And iterative approach, flexibility and focus on the end user. Because you're developing with the customer in mind, they're having a constant feedback, so your end user is getting constantly changed. Another question, this was from the mock last year. Discuss the potential benefits and challenges of moving a design team from Waterfall to Agile. So what is the advantages of moving from Waterfall to Agile? Again, it's quite nice because it gives you the whole kind of circles and what Waterfall and Agile is. So nice question to get. Just potential benefits from changing from Waterfall: flexibility and adaptability, creativity and innovation, time to market, lower cost, improved satisfaction and team cohesion. Okay, challenges: scalability, so changing from one to the other can be quite hard because it takes a while to get that change. Training, might need trained in Agile because it's a new methodology, they might need trained up. Deadlines might be missed, not suitable for simpler tasks or projects, and requires more planning and managerial oversight because the manager has to keep on top that they're doing the product backlog, okay? So just in both of them, Teamwork is massive in collaboration. So that's why the ALTs are in computer science. So teamwork between project manager is basically over the whole project. They're in charge of and that's in Waterfall. They're in charge of time, money, all that there. They're making sure everything's done and everyone's working the one task. A Scrum Master then, slightly different. They're facilitating them meetings that everyone's standing up, saying what they did each day and making sure everyone's working towards the product backlog, okay? The list of requirements the end user gives. Again, last question of an exam. Again, identify 2 roles would be appropriate for this project, and for each role, outline 2 responsibilities associated with that. So a project team and assign the roles. So what is the roles within a project team? So you say what the role is, and the responsibility. Again, there's your roles if you're different in both Waterfall and Agile, and what's the responsibility. Again, that was a long question, 8 marks for the SDLC. Okay? So that's basically the SDLC. Very quickly, you can go into more detail. So you need to know testing in more detail, and you probably need to know design in more detail, like wireframes and UI and stuff like that, because that can come up as well. But that's the Agile versus Waterfall approach. So you have a 15-minute break now, and then when you get back 11:15, we will start into coding one of the mocks from last year. All right? Right, so in this session now, for about next hour, we're going to look at last year's mock, section C. We're going to work through it. I'm going to give you each part, and you're going to have about 5 minutes to work through, and then we'll work through the solution with you. There's a reason why I picked this question. It's working with an external file. So you have to use the external file. It's a poem, and that you're basically opening that poem within the Python file. So it's looking at kind of a different kind of style of question that probably, I don't know if you have seen this, some of you might have, but it's just showing what may come up on your Leaving Cert data. It mightn't just be your for loops, while loops. You might actually have to read in from an external file. Again, I know Gary would have mentioned this to you yesterday, the importance of this sheet, but really it is important that between now and your exam, you're using this in class. It doesn't matter, there's PDF versions available on your examinations.ie. Print it out, even just have a PDF version on another tab. When you're doing any Python now, try this. This be your first go-to if you're doing a question in class. If you run into a problem, use this. Don't go on ChatGPT or don't go on Stack Overflow or something like that, okay? If you can't get the solution from this, then go on ChatGPT and copy and paste it in, or go on Stack Overflow or Google your question on and see can you overcome it. But you need to know how this works, know all the operations, because it's only what's on this sheet will come up in section C, okay? That's it. So anything that's not in this sheet will not appear, basically. Of all the other years, anything that's been on this sheet is what comes up in your section C. If it's not on this sheet, it usually doesn't come up, okay? So it's important to make yourself familiar with this now. By using this, you'll improve your programming skills as well. You don't need to know anything off by heart. You don't need to. You just need to be able to reference from this. That's why it's called a reference guide. You reference from this sheet, okay? There's 2 sections. I'm missing a section at the bottom of that, but has anyone not seen that before? Okay. If you are doing Python tasks now in class, which you will be because you have a 20% exam in section C, start using that, okay? Do start using that instead of anything else. So, section C, a few tips for you for helping you out on this. And again, as I said, it is worth 20%, quite a lot. So between that and your project, you're looking at 50%, okay? 30% for your project, 20% for the Python, and then 50% for your theory, okay? So it is quite a nice chunk. So first thing, if you have something, so when you're doing this, you're usually given, not in this question I'm going to show, but you've probably seen yesterday, you're given a slice of code already. You're given a whole section of code that you're basically kind of manipulating. So if you add stuff to that and it doesn't work, try not to delete it, okay? Just comment it out. Does everyone know how to comment? Just comment it out. Leave it there. You can put multi-line comments in, because you could just be very, very close to the correct answer. You might have just forgot something, or you might have left out a bracket somewhere. You might get partial marks, and it's not going to use up any memory. So just comment out what you've did if it doesn't work instead of deleting it, okay? That would be my first thing. Again, recommended to use the Python reference guide between now and the exam, okay? I give it out to my 5th years in the first week because it's worthwhile to use it. Like it's there to help you, so you need to use it. So if you aren't used it, use that between now and your exam. It is really, really going to help you, okay? It's the only support you'll have in the day of your exam is that guide. And then another thing is, it's not advisable to spend too much time on a single part. So what you'll have is, in your exam, you've question 1 and you've question 2, okay? Question 1 is usually a scenario-based question where there's about 5 parts, and each part isn't actually explicitly linked. So if you do part 1 and then run into a problem in part 2, part 2 isn't usually not linked to part 3 or part 4. So if you can't do part 2, skip to part 3 or part 4, because part 4 might be put in a comment somewhere, okay? So just because you run into a problem one part, skip to the next part. Don't spend too much time in it, because this is really, as you've probably seen in your mocks, this is really time consuming, that it flies by. So you've only 1 hour to do the 2 questions. So if you do run into a problem, just skip it, okay? And then come back to it, like you do in your written exam, come back to it at the very end and see can you try and solve it. So just comment out code instead of deleting it, use the Python guide, and then skip parts if you run into a problem, and then come back to it, okay? So what we're going to look at today is, as I said, this came up in last year's mock, okay? And what it is you have a poem. So this here's a poem, by Percy Shelley. And what it is just a poem, okay? It's in an external text file. So it's stored the text file. And basically what we have to do is we have to read the contents of that text file into our Python file and start answering questions on it. So it's very kind of similar to your project. If you got your CSV file working or your text file working in your project, you have to create a text file or a CSV file and then read data back from it. Now, again, this can come up because on this Python sheet, the bottom right, and I'll get the Python sheet up in a minute, on the second part of that Python sheet, there is reading from a text file, so it can come up. The other thing that I would say about this part C, section C, that I didn't put in here, tips, every year, the exam, the random modules come up, section C. So do you know that random, import random, random.choice, random.randint, all them random things? Every year it's come up in section C. So do probably familiarize yourself with it. I know you'll be doing past questions and you'll see that anyway, but it is no harm to get used to that as well, okay? But this one doesn't use the random module, so we should be all right. So one of the most powerful aspects of Python is its ability to read in data from external sources and to perform complicated analysis on that data. You'll find a file of a poem by Percy Shelley called shelley.txt in the same folder as your seed file. So this is an external file that we're going to read into our Python and then start doing analytics on, okay? It's not kind of analytics like your Leaving Cert project, it's different analytics like getting out certain lines and counting how many words and characters and letters was in the thing and lines and stuff like that. But again, this is part of skills you need to know because this possibly can come up on your Leaving Cert. Now you can be given a file and you have to read that file because this is on that sheet. Reading and writing files is a section on that sheet. So read the file, open it. You have 2 options. You can read the whole file or you can read lines. And then again, you can loop through the file. So that's what we're going to be looking at today, and then to write the file. So if it's on this reference guide, which this is, read and write files, it's possible that it can come up on your section C of your exam, okay? So just so you aren't going in today if you're Leaving Cert exam going, why is there a file in here? You need to just know, make sure you know how to open files and read into information files. And that's what we're going to do today, okay? So file reading. So that's the link. I use Replit. I know you were using Tawny yesterday. If you don't want to take a picture of that or scan that, that will bring you into a Replit account of mine that will say the ATU file read mock 2021, and you can fork that then from my account into your account. If you have a Replit account, you should be able to fork it. So the nice thing about Replit is if you have the app, you can code on your phone. If you want to download the app, you should be able to also probably download or work Replit on your mobile browser as well. So if you scan that, it should say fork. You might have to sign into your profile to actually fork it. So when you get that in, what it should bring up is you should see, let me see, can I open this? So what it should do is when you go into Replit, it will open up a page like this when it loads. See here? And what you hit then, that will show my you click this fork. See fork over here, top right. You click that, and then it'll fork it and sign into your account with Google or whatever, and it will bring all the contents that's inside this file. So you should have the alt Shelley and the Shelley file in here. So they're the two text files, and then there's your Python program. Okay, again, that is on that file. Okay, so just give you a minute to get that set up. So what we'll do is we're going to work through the questions. I'll give each part of each question, I'll give you a few minutes to try it, and then I'll go through the solution. Okay. So as I said, if you have the Replit app, you can code into the app, or if you have it in your phone, if you don't have a laptop with you. Okay. So text files, part A. Okay. So you should see. You've your main Python file here, and then if you click into your Shelley's, the one we're going to be using with shelley.txt, you should see when you click into it, you should see a poem appear. And that's what we're going to be reading from. So, part 1 of this mock asks you, using the read lines built-in function in Python, open the shelley.txt file, read the file into your program, then close the text file. Indicate that it has worked using an appropriate print statement. The output should look, the poem has been read correctly by the program. Okay, so you want to use the function read lines, and what I'll do is I'll just bring this down here so you can actually see it. Right, so from that thing you've just forked, I'm going to give you a few minutes to see can you get that working. Okay, so can you open the text file, read the contents using the read lines, and say this poem has been read correctly. Okay, so see if you can get that working. I'll give you, it's what time is it? It's half now, I'll give you to 33, okay, then I'll go through. So imagine now you're given this today for your exam and you're asked to read the file. Can you use that to read the file and then read the contents? Right, so I'm going to go through this with you, because some of you haven't did this before, and I know it's hard, but why I picked this one today is so that just in case this comes up in your exam, that you're not going, just never seen this before, like. That is why I picked this one in particular, because it is a little bit different, and it could possibly come up, okay? So you, as I said, you were given that sheet there, file f equals open path, and then read. So the instructions there actually are grand, but the thing of this path is it has like opening like arrows nearly. It actually needs to be quotes. So you're saying what path do you want to open? So what we're going to do, and my change is if you want to fork it again, I'm going to create any variable. I'm going to just call it file. I know they called f. So I'm going to go to file. Hold on, I'll go to a bigger one. Sorry. File. And I'm going to open a file. So anything I open here now is going to be stored in this variable called file. So the path that I want is this shelly.txt file here. Okay? So the path is, I pass it inside quotes, shelly.txt. Like that. Okay? And then you have two options here. There's read and there's write. Write overwrites all the information, so we want to read that file. Okay? Then what I can do is I can print that to make sure it worked. File. And that will probably just show some kind of weird text, and then I close it. So if I press run now, it will show up some input I/O thing. See here, right? That there's reading the file. But if you go back to that guide, see here, you have to actually read the file again and read line off the file. So to actually see the contents inside, we've opened this file. But to see the information inside it, we need to pass the read function to it. So it's saying go to this file and read the contents inside it. So now when you press run, you should have the poem showing out. Okay? So read reads the entire contents. And then what the question, if I go back, what the question actually asks is to say this poem has been read correctly by the program. So it doesn't actually tell you to show the program, it just tells you to open it. So this poem has been read correctly. Has been read correctly by the program. So if I press run now, that should show down underneath my poem. Okay, now that reads the full contents of the file. Okay, it reads everything that's inside it. What it actually asks you to do in the question, if I just pop back one, sorry, I'll just close this one because I keep going to the smaller one. What it asks you to use is, it says in here, use this thing called read lines. See that? Using the read lines. So if I change read to read lines, what it does is it reads every single line and it puts it into a list. So I think he's worked with lists yesterday. And what we can do then with that list is we can start getting data. See here now, every single line's inside a list. And /n was just where it skipped the lines in between. Okay? So if you were given that question there, that is what it wants outputted. So you can show that you've read through each line and then said the poem has been read correctly by the program. So you've opened the poem, opened the file, read the lines here, see they're all inside a list of all the lines, and then close that program. Does anyone have any questions on that? So the difference between read just reads out all the contents, read lines splits every line into a list. So every element in a list is inside a list. So see there's the first item in the list, It's the first line. So from knowing your list methods, how would I get that first line? So if you think back to your sheet here, so just go back. See this here, list. So how do I access the first element of a list? See in list operations, retrieve the item of index I. So where I've said read lines, that's a list. So if I want to get the first line, which is element 0, yeah, always starts counting at 0. If I press run now, that will get me the first line. If I want the 5th line of the poem, which is line element 4, which will probably be blank, yeah, because line 4 is nothing. If I go to line 5, I'm getting the 5th line of the poem, because this read lines method is putting it into a list. Every new line's in a list. Does that make sense to people? Yeah? Okay. So, if I press run now, that should be all inside a list and says the poem has been read correctly. Anyone, any questions on that? Is all clear? So, again, there's your solution. Reading the lines, the poem has been read correctly. Okay. And you can see it might be better to do that instead of printing that. You can store it in another variable to read, that reads the lines, and then you can print that data. So you're just storing it in a variable, reading the lines, and again you can just print that out now. Okay, so it just prints the same things, but you're just storing it in case you change it. So it's the solution to that one. So part 2 of the question is modify the program to output the last line of the poem. When the program is run, the output may look as followed. So it will still say your poem has been read correctly. The last line of the poem, using code to get that last line, you have to output it. Okay? So again, I'll give you another 2 or 3 minutes to get work on that. So you have to use code to actually get the last line. So it will say, in quotes, the last line is, and then that data, and somehow getting the last line. You're not saying the last line is not may endure in a print statement. You're using the code from the file to get that last line. Sorry. Right, so again, I'll just go through kind of the solution to that. So we've stored all of the lines in a list inside here, okay? And we're looking for the last line. So I don't even need to print, well I can print out the contents, I'll print the last line. The last line is, which line is that? So you have all said here, data, and then you've accessed it. So I think element 18 is the last line, isn't it? I'm really sure. The last line is not may endure, and again, it was asking for that inside your quotes. So just make sure, whatever it's asked in the question, make sure to do it, or else you might not get the full marks. So see in the question here, it's asking for them quotes. Just make sure to put in them quotes, okay? So see there, the last line is not may endure, okay? But there's one problem there. Line 18, yes, that is the last line. But what happens if I go in here to this Shelley file and by mistake I just go like that, press run? That isn't the last line anymore, isn't it not? It's not the last line. So yes, it's plus 18 here. You can change that, so you can go plus, but you can also go -1. So -1 will always get the last element in the list. So see there now, it's changed that SDSH that I just put in. So if I delete that, it'll always get the final element in your list. So -1 for the last element of anything, you're probably better using negative index. If I say -2 there, it will get the last, second last. If I say -3, it'll get the third last. Does that make sense? So yes, I know it's element 18, but just better using -1 because that gets the last element. Okay, it's because what happens if they add new lines to the poem? Is everyone clear on that? Yeah? So give you a chance to take that down. So again, just to be sure I answered the questions too, I put in the quotes around it because it asked for that question, just to make sure you get all the marks. Okay, so I'll come back to it then very quickly. So again, solution, so the last line is that data -1. Okay, very, very simple. So part 3, I'll put up the other code then. Part 3 is modify the program to count the number of lines, words, and characters in the poem. Use split, so it's telling you what to do. Use split to create a list. So split creates all the elements into a list, kind of like the read lines that contain all the words from different lines. When the poem is run, the output looks, so what you're doing is you're using a variable of lines, words, and characters. So what are we going to set them to at the start? Words, lines, and characters. We have to set them at the start. What would they be set to? 0. Set them to 0. So every time there's a line, we increase that by 1. Every time there's a word, we increase that by 1. And every time there's a character, we increase that by 1. Does that make sense? So if you're using a list to work out, what are you probably going to use? How do you go through a list? How do you access each element inside a list? Index. You can use index in a list, but if I want to say if I had a list of 5 items, how do I go through each item? Yeah, for loop. Use a for loop. So a for loop to loop through every single item. Okay? So you're going to want to loop through every single item to count that up. So every time it finds a new item, be a line, a word, or a character. You might need a nested for loop to work out the characters or the lines, or sorry, the words. Okay? So if I go back into this, so you're up here, before you open the file, you're going to have your 3 things. You're going to have a line equals 0, words equals 0 and characters equals 0. So from that, can you now try and count up how many lines there is, how many words there is, and how many characters there is, and output that to the user again, okay? So again, all that information, the for loop, what you have to use for this question, the for loop, that is on that sheet, okay? So can you, lines, words, and characters is in the poem. This one is a bit harder, and I know you're probably struggling a little bit more in this, okay? So as you can see, as you go further into the parts, the question is getting harder. Again, this is higher level, so it is going to get difficult. So I'm not even going to use Python's guide or anything, I'm going to just show you something. So say if I have a list of items, right, equals, I don't know, apple, pear, banana, and let's say that up here, exit that, sorry. And last item is, let's say, I don't know, blueberry. Right. So essentially, what we have here is the exact same as data up here, except these are fruits. Our items list has fruits, where this has all the lines of our poem. Yeah? So they're the exact same thing. Now, what I've seen a lot of you doing is you're using this for loop, which is fine, and it can work. So for I in range, and you give a number in here. So if I say 10 there, that loops for 10 times, okay? So I can print I. So this will count up 1 to 10. So it'll count, or 0 to 9, sorry. It'll count 0 to 9, so it'll start at 0 and count up for 10 times, yeah? Now, in range works, but it's not optimal. What you can actually do is you can say for I, so for I in items, right? And what this does, depending on your solution, this will loop through every item and print them out on a new line. So you see there, it goes to apple first, gets apple, so I is first equal to apple, then it skips to pear, I is then equal to pear, then I is equal to banana, then I is equal to blueberry, okay? And it prints it out. So we can do the exact same thing. In our code, we can say I is equal to data, because we have this variable called data up here, and that will print out now every single line. Yeah? Do you see that? So that loops through every line. So if that loops through every line, what we want to do is we want to say every time it goes through one of them, we increase the line by 1. So I will say at the end of that, print back line. I'll just bring that up a bit. I'll get rid of this here one. So what this should do now is this should show me how many numbers of lines I have. How many does that say? 19. Because this goes through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, the whole way up to 19. So you're accessing each line, and then every time it accesses a line, so the first line is 0, and then it increases it by 1. Then it's, when it goes through that line, then it gets to line 2, increases line to 2. Does that make sense? Yeah? You sure? Okay. Now, that counts up the line. Any idea how we can get the words? What did it say to use for the words? So if I go back to the question, what did it say to use for the words? It's telling you there. Split, isn't it? Do you know how split works? No? Right. So see I here. I's looping through, so data, we're looping through every line, and every line is equal to I. Does that make sense to people? Yeah? So I will be the first element, we are clouds. Then how restlessly, that's element 2. I's just increasing every time, getting every one of them. What we can do with I is between, in every sentence, what's between every word? In every sentence, what's between every word? Spaces, isn't there? So that's what differentiates, that's how we know what word is where. There's spaces between. So what this thing that they ask for, so they're actually telling us in the question, what they're saying is split. What this split does is that basically where there's a space, it splits it into another list. Okay? So if I say print I, and I put the word split, okay? So this is what printed out before over here. See what happens now when I press run to the list, okay? What does dot split do? What does dot split do? Yeah. Every line, it puts it into what? A list. Yeah. So every line is being put into a list. Okay? So that list now here, what we can actually start to do is we can count up how many elements are in that list. Okay? So I can say here the word list is that. Does that make sense? So every one of these, so we are as clouds, that's in element and list. Does that make sense? So there's another function on that Python sheet that you can get the length of that. So I can say the length of we are as clouds that fill the midnight moon. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9. That will say the length of that is 9. So if you see here, right, so see where I printed that. So I can say print the word list, and if I pass in, again, it's on that Python sheet, len gets the length of any array. So I'll just print that out. You see there, it's telling me the length of words on the first line of the poem is 9. There's 8 words in the second line. There's 6 words in the third. There's 10 lines in the 10 words in the last line. And then there's 0 words because if you think about it, it skips this, so there's no words in that one. If I go back, do you see that? Does that make sense? How that works? So you loop through, and then you split it by each space, because that's how we know what word is, every word is split up by a space in between, and then we get the length of how many words is in that. So in the first line there's 9, the second line there's 8. So from that there, can you count up how many total words is in the whole poem? So what you're essentially doing is see all these numbers. What do you want to do with all these numbers? Add them together. Yep. So can you try and add all them words, numbers there in the output together to show me how many words are in total in the poem? Lines and 130 words. As you can see, that's probably worth about 15 marks out of that section. See that one, part 3. First 2 parts are probably worth 5 marks each, because they're a lot easier. Right, so to add up all the words together, see where we are printing them there? We just literally say the word variable we have up here, which was set to 0. And what we're doing is we're saying plus equals always adds to it. So whatever, so it'll be 9, then it'll be 17, then it'll be add 6 to 17, then it'll be add 10 to that. Okay? So if you print that now, so I can say number of, what is it asking? So it's saying there are 19, so that will show me how many lines there are. There are 19 lines, and then it's asking for how many words, like that, and then I'll just say the word words, just to show you. So it should show me now how many words in my poem, which should be about 130. Where have I gone wrong there? Too many brackets. Okay, so there are 19 lines and there's 130 words. Does that make sense to you? Yeah? What's the last thing then we have to get? Characters. Okay, so can you try and think? So this is what they say about your computational thinking yesterday. You have to problem solve a way now. From this, can we count the characters? So it doesn't actually tell you how to do that. The lines and words is alright. Can you think of now a way to count up all of the characters? There's 2 ways you can do it. Right. So with this one is again, as the other two are hard. You need to know how a for loop works. If you're struggling with that, it might be no harm going on YouTube. And like, there's literally the best place to learn computer science is YouTube. Like 2-minute videos on a for loop, 3-minute videos on a list, and it will go through and explain. You can go at your own pace. Okay. But again, obviously, then you need to be able to apply that to these questions. So this could be, as I said, something that comes up. So what we have here is we have a for loop that is looping through each line, then split that into a list and basically get the length of that list to work out how many words. So there's two ways you can do it. The first way is we know there's another list called word list of all the words that's inside that. So inside our loop, it's a thing called a nested loop. We can say for word that is in the word list, we can count how many characters is in each word. If I spell word list right. So you can say here that will loop through now so first it loops through every line, and then it loops through every word that's in that line. Does that make sense? So what you want to do is for every word that's in the line, you can literally say characters plus equals 1. And then again, we can now say and characters is characters. Like that. And if you run that now, that should count up to 700. Sorry, it's not for word, it's for word in I. Because I is this. See, I is every sentence, and then for every sentence, for every word that's in the sentence, or actually that should be probably be better if I said for every letter in each sentence, we're going to add the characters up by 1, and then you should have now 19 lines, 130 words, and 713 characters. Okay? Why there's 713 characters, does anyone know?
Including like spaces as well?
Yeah, it's including blank spaces, but if I print I, okay, just to show you, let's see. See at the end of I, okay, Python goes to a new line because it has /n. If you look up here, see all these have /n? See /n up there? /n is actually being counted as a character. So to get rid of them /n's, you have to overwrite I equals I dot strip. It's called strip, which is, it strips away all them words, them /n's. So if I print now every I, so if I print I, it won't skip them lines. So you'll see here now it will just, before there was a gap, where now it just prints everything, because you're stripping away that /n. Okay? And again, that's that part 3 done. Okay? So if I go back here, again I'll get up in a minute. Solution to that. So you're looping through, I'll give you a solution at the end of all the comments and all. You're stripping the line of this to get rid of the /n, that's what that does. You're increasing the line by 1 because that's the first line. You're inside that line, so you're increasing this for every line, you're increasing that by 1. Then you have splitting that line up to have all the words, and you're increasing the words by the length of the amount of words in that line. Okay, because that's put into a list. And then you loop through the letters that are in the line and increase the characters by 1. So you'll count the line, the words, the number of words by the length of the list that you split, and then the characters for the number of letters that's in the line. Okay? And then you just print back at the end. So that is really, really difficult. There's no 2 ways around that. So you need to know for loops and then how the loop actually works. And actually it's a nested for loop because you have a for loop inside a for loop. Okay? So it is difficult. So part 4 of that then, So it says the text file that there are 16 lines, not 19 lines. So it says they made a mistake. So if you didn't get the last part done, you could probably try this. You mightn't have got all the characters and the words thing working, but you could see maybe you got the lines part working. You can go on then and do this part. So there's 16 lines and not 19. Modify the program that the correct number of lines is shown when the program output is run may looks as follows. So you have to change it that essentially in here where it says 19 lines, it should say 16. But because there is only 16 lines, it's counting these spaces. See here, the spaces. So can you come up with a way inside your code that we somehow can skip them spaces so it doesn't count them spaces? Okay, again I'll give you another 3 minutes to do that. So can you, where it's counting up the lines, if there's a space, it will skip. So you can fork and get this part up, because some of you probably are coding. So let me show you. So if I go back here, if you scan that again, that will bring up my latest one. So if you want to scan that, you can fork it. It will just bring up the latest one, that most up to date what I have there. Because I know it's not easy to follow. Right, so then when you have that forked, you're then working out, so it says 19 lines a minute, you're trying to get it down to 16. So there's lines there with nothing in it. Can you somehow work out to get rid of them? Okay, so part 4, get rid of them. So it says 19 lines, can you get down to 16? Okay, so it's not 2 minutes now because I know it's going to break again, and then we'll just wrap up that. There's actually another part we're going to not get time to cover. Right, so I'm aware I want to get you off to lunch, just so we're on time. So just be 2 or 3 minutes to do it. So what we have is, it says 19 lines a minute. Okay, why it's reading 19 lines is inside our poem, there's these lines with nothing in it. Okay, so inside our loop where we're counting up the lines, it's very, very simple. We're basically going to say if the line is equal to nothing, or the length of the line is equal to 0, we're going to skip it. Otherwise, we're going to count that line up by 1. So if there's something in the line, we'll count it up by 1. If they're empty, we skip. Does that make sense? Okay, if you were to think of that logically, if you were to stand there in English and start that out, you'd say, well, where there's nothing in a line, we'll skip it. Where there is something in a line, we'll add 1 to it. Okay, so if you go back to your code up here, back this way. So in I is every line, okay? So what we're basically going to say is where we see down here where we increase the line by 1. We're going to say if I equals nothing, you can do it that way. We're going to say continue. Continue is just a loop that means it will just continue on with the rest of the code. Otherwise, if there's something in the line, we want to do increase the line by 1. Like that. Okay? So now if you run that, it's just a simple if statement, you'll see now the lines are back down to 16. So you're saying if the line is blank, continue, because this else won't run. This will never run. So it will do just continue on with the rest of the code. And it will say if there's something in the line, because that's the other condition, we increase lines by 1. Simple as that. Just a simple if statement. So if it looks more complex than it is, 4 lines of code did that. So if it's empty, we continue and do nothing. If there's something in it, we increase lines by 1. So that gets rid of them 3 blank lines. Does that make sense? Yeah, is that straight enough forward? No, I know that is difficult. So just before you go, I have a full solution. So that took us an hour, and we only got 4 parts done of 1 question. You have to do 2 full questions in your section C. So we have 1 full, so part 5 is to put in a search. So you have to actually allow the user to search in the poem for a word, and it tells you back if that word's there or not. And that's 1 full question done. You'd have to do another question then, and that took us a full hour. So timing inside this is massive. Okay? So that's the finished solution with all of the parts done, parts 1 to 5. And also on that as well, there's the part B. I have it all in the PowerPoint if you want to look up. So you can fork that solution. It has all comments with all the code of everything you need, but it just gives you an understanding of how tight for time you'll be in your section C. And just to be aware that when you're practicing your exams, do be looking at reading files and looping through them files. You need to understand how to do that. And some of you probably need to look then at for loops and stuff, how for loops work, different range compared to looping through a list. Okay? Anyone any questions on that? No? Is all okay? Just to make you aware that yesterday I know you did an early level and a higher level question, but that's completely different. You can see you need to read from a file. Okay? So I'll let you run on now to lunch, and then after lunch then we're looking at like electronics and the CPU. Okay? And I'll see you as soon as you get back. Okay, so welcome back. So we're into the evening session now of the workshop, day 2. So what we're going to look at in the evening session is electronics and the CPU. But first part, we're going to look at electronics. So electronics in the course is done through ALT4, which is your microbits. Hands up. Has any studied the microbits ALT4? No, you do microbits, yeah? Did microbits? Yeah. So most of these probably have done them. So you know the course split up into the 4 sections. We don't do the JavaScript, which is the ALT1. That's not on your exam this year, so you don't need any know of that. You did ALT2 and ALT3 probably a lot this year, your data and analytics and your modeling. And then ALT4 is your microbits. And the microbits really kind of relate into electronics. To be honest, it's probably not computer science, it's more into electrical engineering department, okay? So we're going to look at the electronics part of the course. So for this, the learning intentions is to understand the basic principles of electronics. So we're going to look at some of the components inside electronics you probably have used with the microbits. Then we're going to move on then to CPU, look at the components and basic functions of the CPU, know what the CPU does, the instructions, how they're fetched from memory and executed, so the fetch execute cycle, and then von Neumann's architecture. So why was von Neumann's architecture invented and what it is, okay? So we're going to look at that over the next hour. So for electronics, what we have, all electronic equipment need voltage to basically power them. So voltage comes up, and some of you did your mock this year, anyone who did the exam prep mock, first question in your short questions was what's voltage and current. Voltage is the force that drives the electric current through a circuit. So it's the force of power going through to basically supply energy to your electronic component that will power it. So whether that's a light or whether that's your CPU, all electronic equipment needs power, and this power is coming from volts. This is measured in volts, okay? The biggest one is your battery. So your battery comes out the negative, goes up into your light, gives your light, and comes back. You have to ground your connection into the ground. So your voltage is the force that drives electric current through a circuit. So then what is current? Okay, so current's the flow of electrons through the circuit. So your voltage is kind of your force. Your current then is the flow of charge in a circuit. Okay, and this is measured in amps. So it's very important to know the flow. And the current flows in the opposite direction to the electrons. Okay? Electrical flows through a given area or volume. So your voltage is like your force, your current then is how that electricity flows. So we have that broke down, kind of what is the difference in twos, down to an analogy of a tank of water. Okay? Voltage is the cause of current, while current is the effect of voltage. So in here we have a big tank, okay, of basically a drum of water. Voltage is the pressure going down. So the more water you have in, the more pressure is being applied down here. The current then's the flow. So obviously if you have more water in here, more voltage, the current is greater. Okay? If that water's tucked down here, the current's going to be a lot less. There's going to be a trickle thrown out. And it's the same in electricity. Voltage, the higher the voltage, the greater the current. Does that make sense? Okay. Electronics does come up, even though it probably isn't computer science, but it's on our course. It's more kind of electrical engineering. Okay, but I suppose it does relate to computer science. So if this current becomes too much, how do you regulate current in electronics? Resistors, yeah. Okay, so we bring in a resistor. So if the current and voltage is too much, and what will happen there is the circuit will basically blow. It will go on fire. You'll basically blow it up and it will not work. Okay, sure, you've all plugged in something before and it blew up. It's not going to work again. How do we resolve this? We use resistors. There, your resistor is basically a component to resist the flow of electric current in a circuit. It resists, so the current flowing through, it resists the amount. The way a resistor's worked out is that they're color coded, like this. Okay, so this did come up in one of the mocks, I'm not sure. It gave you this chart, and from this chart you had to work out the resistance of a certain code. So based off the colors, there is certain digits, what they're multiplied by, and then the amount of tolerance it has. So the more voltage going through something, the more higher the resistance needs to be. Okay? And this is how you work it out. You can work it out from this table. You don't need to know that table or anything off by heart. That table will always be given to you if it comes up. But it's just how, when you look back here, all these color coded means there's different types of resistance. So you're going to have a resistor for 3 volts compared to 20 volts. It's going to be different, okay? You're going to need the different types of resistor. So a resistor resists the flow of electric current in a circuit, okay? So see here, we can put a resistor into this where the flow, the voltage is still being pressed and the current's coming out of the height of the water. Then you can put a pipe at the bottom to basically resist the current. Okay, so if you want less current coming through, you can put a resistor on it. Same analogy of the water. Does that make sense to people? Okay, so a resistor reduces the current. Okay, you can resist it. So the first kind of component we're going to look at, well, second component we've looked at the LED, or the resistor, is the LED. Okay, very, very simple. It's a light emitting diode. That's what LED stands for. It's a semiconductor. Okay, so you'll hear that. We'll look at that in more detail in a minute. Semiconductor means it can insulate and conduct based off certain situations. Light source that emits light when the current flows through. So when it has power going through it and grounded the other side, the light lights up. Okay, that's what an LED is. So I'll just show you this. If you want to scan that, it should come up. It's a little circuit, you can play around with it. So there is quite a few QR codes if you want to have your phones out. Or right, so what this one is this is a website here called Tinkercad. It's very good for electronics. You can build circuits with the microbits or with batteries. You don't actually need the physical goods. So even though you do ALT4, which is your microbit, you can still be asked theory on it.
Could you put that thing back?
Yeah, perfect. Okay, so that website, again, you might need to sign up your Google account, but you can build circuits on it very, very easily. As a great way to kind of understand. So you can always learn the theory behind these electrical parts, but it's a better way to kind of understand how electrical components work. Okay, so in here we have our microbit. Okay, so you've all seen this. This microbit is connected up. So it's kind of a bit of a mess in a minute, but we'll go through it. So on this website, you can code it over here. So I have it coded that when we press button A, the lights turn on. When we press button B, the lights turn off. Okay. So if I press start the simulation, okay, like this, and if I press button A, okay, you'll see the lights turn on. There's 3 things here. Okay, there's 3 parts. So the first one is, when I press button A, this one's giving me a warning and this one isn't. I don't care to tell me why one's giving me a warning and one isn't. Yeah, one has a resistor built in. So why is it giving me a warning? Because there's too much voltage getting to this one over here. So it says there the current through the LED is too high. The usable lifetime of the LED will be reduced. So hence why we put in a resistor to resist the amount of energy. That one there is lit up. I know it is hard to see. If I press B, they turn off. Press A, turns on. You can see it light up and light off. Okay? So the resistor is resisting the amount of energy. Without it, you get a warning that the LED might light up, blow up, or the lifetime of it is reduced. Does anyone know what this thing's called up here? Nah, not a transistor. Good guess though. It's called a potentiometer. See here, potentiometer. Right. Anyone know what it does? Again, it could be asked what a potentiometer is in your thing. Okay? So what it does is, you see here, the black, always the black in my circuits is ground. So the black's connected to ground, which is in the far right terminal. You have a middle terminal called a wiper, which is connected to my power. And then you have this terminal here that's connected to the light, so it's emitting the energy. What this thing does is, this is like a little knob at the top that turns. Okay? And what you can do with that is control the light. See there, it's light up. If I reduce this slightly, it's like partially on. If I go halfway, that means it's halfway on. If I go down here, it's off. So you can see it's actually controlling the rest of them too. See, all the rest of them are turning on and off based on what I do. So if I turn that off, a potentiometer, the way it works is it works analog. So use all digital. What's digital? Do you know what digital is compared to analog? Digital is 0 and 1. So it's either off or it's on. Analog goes from what? In the microbit anyway. Analog goes from 0, which is off, to 1024. Okay? So what you can do with this is, if I set this up here halfway, that's roughly 500. So what it will do is it puts the brightness to this here to half. So it's half on, basically, the brightness is set to half. Does that make sense, people? So a potentiometer, you can control kind of the analog value, okay? The rest of these A and B buttons are digital, on and off. So if I press A, it's on. If I press B, it's off, okay? Does that make sense? Yeah? Right. So this is a question that came up in a mock last year, I think, or 2 years ago. No, it was last year, yeah. So the image below shows an embedded system, microbit, and the microbit then is connected to a breadboard. Do you know how a breadboard works? Does anyone not know how a breadboard works? Let me show you. Yeah, that's all right. It's perfect. That's what today's for. So electronics is kind of important. So see your breadboard here. Okay, so there's little breadboards. I'll bring in one here on the left. So usually the breadboard you have is this one. See here, like that. Okay. Let me just zoom this out. So the way a breadboard works, where's that falling up now? Bring that over here. Bring that over here. Right. You'll see when I hover over these that these will light up. Okay. So on your breadboard, you have a plus and a negative on both sides. Okay. So where these on both sides, when I hover over them, the whole line lights up. See that whole green line? So what I can essentially do is I can connect the negative of that to the negative of my microbit. That allows me to connect here. Okay. Let me see. I'll bring in an old microbit. Easier. Bring in a second one. So my ground here, I can connect to the negative of that. So that means now that whole thing, that whole line there is negative. So the other side is 3 volt. So see my positive side, I connect that to the power, which is 3 volt of power. So that means now any other signal on here is negative and positive. So if I brought in, let's say, an LED, my breadboard basically extends the connection. So this LED, cathode always connects to negative, which is your short side. Your long side always connects to positive. Because this is coming through to now negative and positive, if I start that simulation, this light will turn on. Even though it's not directly connected to my microbit, this breadboard connects as like more access points to the microbit. Again, the side one is the whole length. If I want to use these inside ones, okay, so I can bring a negative, let's say to J. See how the inside line lights up? And then let's say I bring my positive down to this side. I'll bring it down here somewhere. So again, I can bring in another LED that negative on the, so the long ones at the top are along this line. The shorter ones are just along the 5 pins. See the 5 pins there. So what I can do is I can go negative to negative, positive to positive, and again, if I start that simulation, that light lights up as well. Although it blows my microbit because there's too much power coming out of it. That's how a breadboard works. It conducts the circuit through the pins, okay? And I know that does look a bit messy, but that is how a breadboard works. So the question that came up 2 years ago was, were for your breadboards, and your breadboards here have the transistors, so you're bringing it down, it's going along this line, you're transisting over here, and it's turning on with your negative on the negative line here. It's the same whole thing. So where there's 5 pins, it goes across, the long ones goes down the whole side. So you've connected. The LEDs are programmed to using timers. So red sequence, 1 minute on, 2 minutes off. Green lights, 2 minutes on, 2 minutes off. Orange lights, 1 minute on, 1 minute off, okay? So you have to work out the sequence, okay? From that there then, from the sequence, when they're all off, it gives you an overall color. So like so when red is off, red's on, the other two's off, it's red. If red and green's on, it's yellow, okay? So it gives you an overall color. So the question asked you, using the table, what will be the overall color in the 9th minute after the microbit starts? So you had to say in minute 2, what happens? So on minute 1, it's on, the green light's on, and the yellow light's on. So they're all on. So minute 2, the red light will be off, the green light's still on, and this light will be off. So the overall color will be, what will the overall color be for minute 2? Green. Yeah. And it's just working through them. Okay? You probably don't need to know how the breadboard or anything works. You need to read this sequence. So that was from a mock. That was from last year's mock. I think that was actually ordinary level. Okay? But that you had to go through the sequence of what was the overall color based off the on-off from reading this. Does that make sense? Okay? I don't think there is a marking scheme. So the next electronic part is a capacitor. Has anyone ever heard of a capacitor? Some of you probably have. Basically what a capacitor does is it stores energy. Okay, it stores a charge of energy. And where it's most popularly used is TVs. Do you know when your TV, after watching it, you'll turn it off and the red light will stay on? And then eventually you may come back in 5 minutes and it's off. What that's doing is it stores the charge for that little light to keep it on. Okay? So if you even plug out the power, that light, like if you plug out the electrical plug, that light will still stay on. Because what it does is the capacitor holds the charge of electrons. And it will store that little charge to let the light stay on. It's used in RAM and touch screens too on your phone. So again, there's QR code there if you want to scan it. Get this clicked on. So again, it's another circuit with the use of a capacitor to show you how it works. I think this one actually has a breadboard in it to show you how the breadboard works too. Just click out that. Right? So this one again has our breadboard. Okay. Well, can I make that bigger? Let me just make this bigger. So what it does is you have your 0 and 1 connected basically to our breadboard. You have this thing here, it's called a polarized capacitor that's going to hold the charge. So what I want you to do is when you press A on this, when it starts, they both light up, if I can zoom in. And then when I press B, they turn off. And what it should be doing is, if when I press A here, see the blue one slower to light up? See that? What is actually happening with the blue one? The red is connected directly to the microbit. The blue one is connected to the capacitor. So what we have to do for the blue one, why it's slower to light up, when the blue one turns on, this here's also charging up, so this here's storing all the energy, and then it finally turns on the blue one. Now, the Tinkercad doesn't do this, but what would happen then in real life is when you press B, the red one will turn off first, and then the slow one will dim down a lot slower. So a capacitor's holding the charge to kind of keep the blue one to slower release of the energy. Okay, and that's all a capacitor does. And these parts do come up. They've come up nearly every year as well, of a capacitor and your LEDs. Next one's transistor. Okay, very, very popular question in the exam. Does anyone know why transistor is so important? Using keyboards? It could be. I don't know if it is using keyboard. I don't know. It probably could be. Why a transistor is most important is inside your CPU. What's inside your CPU? These are inside your CPU. Now, this one here is called a negative, positive, negative transistor. It's called an NPN transistor, okay? But the transistor inside your CPU is really, really basically microscopic versions of them. Does anyone know in the latest iPhone how many transistors are in it? Huh? Few how many? Does anyone know? There's roughly over about 10 billion transistors in your CPU of your iPhone, the latest iPhone. What they are is they're all linked back to like logic gates. So a transistor is, all you know binary numbers? Yeah, it's 0 and 1. Essentially what this is when it's 0, it's off. When it's 1, it's on. But when it changes to 1, it basically regulates and acts as an amplifier to the circuit. So it actually produces more energy that's going to it. It's a device that regulates current or voltage and acts as a switch or gate for electronic signals, and it amplifies that signal. Okay? Transistors consist of 3 layers of semiconductor material, each capable of carrying current. A transistor regulates current or voltage flow and acts as a switch or gate that amplifies the signal. Okay? It's very important that you know this transistor because, as I said, you'll see now in a minute, it comes up a lot of times. Okay? So there's one of the questions. Outline the function of a transistor in a computer system. So you have to say and explain what the transistor does. Okay? So we'll just look through what the marking scheme says of that. So you outline a transistor. So this is the definition you need. A transistor functions as a switch with binary function. So it's either off or it's on. Okay? It contains certain voltage, it is on. Less than this voltage, it's off. A computer can carry out billions of operations per second because the transistor can change between these states on and off, many times a second. And there are millions of these transistors inside a computer. Okay? It amplifies the signal. It changes just from on to off. That's all a transistor does. Okay? And there's billions of transistors inside your CPU. It all links up to that logic gate, doing your logic, your NOT, your AND gates and stuff like that. Half adders and full adders. Okay, so if you want to even get a photo of that, then it's on. It's all the PowerPoints are on, and I'll give them to you at the end. Again, so explain why data. So again, explain why data is stored in computers in binary form, even though it's nothing really to do. Doesn't mention transistors there. You can bring transistors into that question. Again, that came up last year in the exam. Explain why data is stored in computers in binary form. The circuits in a computer's processor are made up of transistors. Okay, so that's why it's related to binary. That's why everything's stored in binary, is due to these transistors. A transistor is a switch that is activated by an electronic signal it receives, and then signals are either on or off, 0 volt or 5 volt. And then the digits 1 and 0 can be used to reflect the on and off state of the transistor. Okay? And then again, the other definition there is there are only two possible states. Binary is more reliable than any other number system. But the transistors relate back to this binary on and off. So a transistor is either off or it's on, and there's billions of them inside your CPU. Okay? And it's important to know back here what they look like, because it might show a photo of them and say label this. So you need to know what each of them things look like. Okay? So that's again just to show you a live kind of version of it. You don't need to click this one, but I'll show you how they work. So this is a transistor with a DC motor load. It basically why you'd put a transistor in this, it'll amplify the performance of the DC motor. The DC motor will go a lot quicker with the transistor involved in it. This circuit loads. Let's see. It's just slow to load. Right, so here again, see, can I go into this? So we have our circuit, okay? Right, so one DC motor is connected directly. The other DC motor is connected with a transistor. So that's your NPN transistor. So it's called negative, positive, negative. So we have one side connected negative. We have our controller connected to the base, and then the other negative side connected to the negative of our DC motor, and then the DC motor also has power coming from the microbit. So if you look, the numbers of these compared, so if I start this simulation, okay, I press A on both, A turns on both, okay. If I zoom in, the one on the right hand side with the transistor, rotations per minute is 5,585, compared to the one on the left is 3,397. Why is the one on the right higher? They're kind of similar circuits. The transistor, yeah, the transistor's causing that. Because what does the transistor do in a circuit? Amplifies it. It amplifies the output. So even though it's getting the same 3 volt and the same ground, this here transistor here is amplifying it. So this one's getting 5,000 rotations compared to this 3,000. Okay. So yes, it's to do with binary numbers, 0 and 1s, but in a single transistor like that, it amplifies the circuit. It amplifies the output of the circuit. Does that make sense? Yeah. Right, so the next one then again, this come up in your mocks this year, some of you is exam craft I think. It's asked about the integrated circuit. So what's an integrated circuit? These here little things are integrated circuits here, okay? Again, it's a miniaturized electronic circuit it's made up of all different components. There's transistors in there, there's diodes, there's capacitors. It's made up of multiple of them components that that are all integrated into a small circuit. Okay? That's, and it usually has a semiconductor as well, that's silicon. So, what is semiconductor? Okay, semiconductor is a material that has electrical conductivity between that of a conductor, which conducts electricity, and an insulator that insulates the electricity. Okay, it's a mixture of the two. And what it's used for, it's used for all the electronic devices. So all them transistors, integrated circuits, all them, they all have this integrated, or this semiconductor inside. It's basically silicon that acts as an insulator and a conductor. So there's a term, again, this come up in your mocks for examcraft, doping. What is semiconducting doping? Doping is basically, it's an impurity. It's a material, an impurity material that's put into the semiconductor to make it either more of an insulator or more of a conductor. And based off the signal it gets, it will work off that. With like a transistor, if it's on or off, it can work between certain signals. Okay. Again, the doping thing did come up in the exam. And then by doing that, it allows it to be used in more electronic applications. So this question here I want you to try now. Okay. So in 1965, Graham Moore of the Intel Corporation predicted that the number of transistors on an integrated circuit will approximately double every 2 years. Prediction came known as Moore's Law and has turned out to be very accurate to the present day. Explain the terms transistors and integrated circuit, and then down here, state one reason why Moore's Law might not remain accurate in the future. Okay, I'll give you 2 or 3 minutes to try that question, and then we'll go through the answers. So when something like this comes up, even transistor, try and write what you know about a transistor. You should get the marks. What do you know about an integrated circuit? Be careful when you're reading the questions too. State one reason. Look at the term they're looking for. Explain. Let's give these another 30 seconds and go through the answer. So in terms of transistor, what did you write?
Current or voltage.
Yeah.
Amplify the signal.
Yeah.
Optimum output.
Yeah, perfect. Good. Integrated circuit.
It's just like an IC is a mini circuit that consists of like transistors, resistors, etc.
Yeah, perfect. Again, correct. We'll look at market scheme now. Then one reason why Moore's law might not be remain accurate in the future.
There's so much transistors you can fit in CPU.
Yeah, there's only a certain amount of space within inside a CPU you can fit. That keeps doubling every year. They can't make it so small you can't see it. Okay, so there's only a certain amount of size. So basically everything you said. So transistor, there's your marking scheme. So that was worth 5 marks, that whole question. Semiconductor device, they said amplify or switch electronic signals and electrical power. Transistors, fundamental building block of gates, logic gates. Transistors are used to represent binaries, ones and zeros. So I'd say you said 2 of them, 2 of them you'll get marks. Okay. Integrated circuit, electronic component contains multiple discrete components. You said transistors and capacitors, stuff like that. Into logic circuits on a single silicon board. Why silicon? What's silicon again? Yeah, semiconductor material. So silicon is semiconductor material. Okay? And then again, part B, there is a physical limitation to the number of transistors that can fit in a single chip. So it can't keep doubling. At some point it has to stop because there's not going to be enough room on a chip. As much as they're trying to make them smaller, it's not going to be possible. Does that make sense, the electronics in that? Okay. So the next thing then we're going to look at is how do we supply the voltage and the current to these devices and to these parts. Okay. You've all heard of DC and AC before? You have DC devices and you have AC. So DC stands for direct current, AC stands for alternating current. And it's very, very simple. DC flows in one direction. Devices that need DC is all electronical devices need direct current. Okay? Because if it's alternating current, it's flowing back and forth and it's not always getting full power. So AC would be used for like fridges and electrical lines is AC, the current's flowing back and forth. Where DC it's direct, like your CPU needs direct current. Because if it loses it, what kind of device is CPU, RAM and all them there? CPU, RAM. They're all DC. Are they volatile or non-volatile? Does anyone know? Volatile. So do you know what volatile means? Right? So volatile means when it loses power, what happens? All the memory is lost. Yeah. So that's why it needs DC. It needs a direct current. It needs power all the time supplied to it. Okay? So why the CPU needs DC? CPU requires DC power supply to function properly. It's all to do with transistors. Transistors need regular supply. And the fundamental building blocks of modern CPUs require a steady flow of electrical power to operate. Transistors, again, are electrical devices that are used to switch and amplify electrical signals, and they are used extensively in CPUs to perform calculations and execute instructions. These transistors are made up of semiconductor material, which is silicon, that require a steady flow of electrical power to operate properly. Okay. Now I know that is a lot, and that is hard, but them electrical parts, like the capacitor, transistor, comes up nearly every year. The CPU, what's DC versus AC? You need to know that. Okay, it is quite a popular question. Again, there we go. There's a question come up 2 years ago. Explain why direct current is needed for the CPU to work. So they asked why is it needed? It's a long question that basically you'd fill out all them lines. So why is DC needed? Okay, so now I'll get you to do that one. But why is DC needed? Again, it's to do with registers inside the CPU, but more the transistors only operate on a clean DC power producing binary in its forms of ones and zeros. The basic structure of a transistor precludes the current used from changing direction, which in an AC setup. So basically, if it's AC, the alternating current is going back and forth through the transistors. So the transistors is always changing from ones and zeros, and it's going to mess up everything. That's why it needs direct. It's always going the one direction. But you can see there, if you see when you see DC and CPU, you need to mention transistors, or else you don't get the marks. You could say CPUs need direct current because it always needs power on. You don't get the marks. You need to say transistors. If you're looking for your H2, H1, you need to mention transistors and probably registers too that hold the next instruction. But definitely transistors need direct current to function properly, and it's all to do with the ones and zeros. And everything in computers is back to this binary, ones and zeros. Okay? So that's kind of the electronics. And what we're going to flick on to next is the CPU. Okay? So what is the CPU? Okay, so it's following on from this direct current thing. CPU is the primary component of a computer, carries out most of the processing and computing tasks. It is known as the brain of the computer. It is the brain, okay? It's doing all the calculations, all the processing, everything's being sent through it. Okay, the CPU is the brain. CPU is responsible for executing instructions that are stored in the memory and then performing arithmetic, like mathematical calculations and operations. And it controls the input and output operations. So my keyboard here, I input something, it's going to be output on this monitor and up here. Okay, so that's your input devices. Any other input devices for computers you can think of? Mouse, keyboard, anything else? USB, it'll be more a memory device. USB would be a memory device. Microphone would be an input, because you can input from a microphone. What? What?
I was about to say that what if the computer is like a touch screen? The screen.
Yeah, touch screens. Yeah, an input. So then what would outputs be? All the outputs. Monitor. Audio, yeah, speakers, projector. Basically your touch screen as well, your LCD display, projector here. So all different, so that's your input and output devices. So the CPU itself is a microprocessor chip that is typically mounted on the motherboard. What's usually over the CPU? If you have your CPU, what's usually over it? There's a big fan. Why would there be a big fan over it? Keep it cool. Okay, it operates best at an optimal temperature. Okay. The CPU is one of the most important components of the computer, and its performance can be greatly affected the speed and efficiency of the system. Okay, so CPU, you'll often hear you have a slow computer, if you upgrade the CPU, you will improve. A CPU is cheap or dear? In comparison to something like RAM or something, is it cheap or dear? Dear. It's probably one of the most dearest. GPUs probably have gotten a little bit dear, but CPUs are probably €200-300 for i7s, i9s. Okay? So what we need to know is we need to know the different parts of the CPU. There's different parts inside the CPU. So there's the ALU, which is the arithmetic control unit. Then there is the control unit, the cache, the buses, the register, and then the storage units. Okay? So all these parts make up the CPU. So the first thing is the bus. Okay? Bus is just the wires that is transferring the data. So if you think of a bus, the bus moves from Letterkenny to Derry. Same in this. It's just moving data from one place to another. Clock. The clock inside the CPU provides a timing signal that synchronizes all the events between the RAM, the CPU, the cache. It's all synchronizing up all of the events. Okay, that's what the clock does. The cache then is built into the CPU, and small amount of high-speed memory that is used to store frequent access data and instructions. So do you ever hear your Google Chrome slow? What do they tell you to do? Clear cache. Because what it does is cache is holding in Google Chrome all your images so the pages load quicker. Same in the CPU. There's three levels of this. There's level 1 cache, level 2 cache, and level 3. Level 1 is really quick. It's only about 3 megabytes, 3 to 5 megabytes. Level 2 is a little bit slower. It's about 15 to 25 megabytes. And then there's level 3 cache, which is about 100 meg, okay? And it's just holding little bits of information. So it's quicker to get the information from cache. Where does the CPU usually get its information from? Don't know. It's usually getting the information from RAM, but if it's in cache, it's quicker access from cache than RAM, okay? Then the three main parts of the CPU, these are the three main ones, is your control unit. It's basically fetching the instructions from memory, which is usually either cache, but it's usually RAM, sometimes cache, and executing them by coordinate the activities. So control unit, think the word control, it's controlling all the activities, okay? The ALU then, if you hear the word arithmetic, you always think of maths. So that's all it's doing. It's a component that's performing mathematical and logical operations, okay? That's all the ALU is doing. It's doing the maths inside the CPU. And then registers are basically holding data of the next instruction for the CPU to do. So it holds the data for the control unit, goes to the register and gets the next instruction. This is called the fetch execute cycle. That register then sends the instruction of the next instruction. The control unit sends that to arithmetic, which is doing some kind of whatever calculation on it, and then again goes over and over again. Keeps doing that process. Grab from the register, send to the ALU, and over, repeats, okay? So you see here, grab the instruction from RAM, into the control unit then passes the ALU, and same process repeats over and over again. So the CPU design, specific design composition of a CPU can vary depending on the manufacturer. Okay, so who's two big manufacturers? Intel and AMD. Okay, and then modern CPUs are incredibly complex and contain billions of them transistors. Okay, so it's all linked back to this transistors and other components all working together to perform complex computations and operations. So we have our input device of our let's say our mouse and keyboard. That's connected to a port, USB port. Then that USB port's connected by buses, which is inside your motherboard. There's buses to connect all the parts. That then's on the motherboard. It has the processor, the chip. Then the bus is also connecting the RAM, the hard drive, which is also inside the motherboard, inside the case of the computer. And then this is an older one, but you'd have then connected CD, USB stick, stuff like that there. Okay? And that's all then going back out the bus and sending it to your output device, which is your monitor, your projector, to output the information. Okay? That's how your computer works. So we look at this thing called the fetch execute cycle. So this fetch execute cycle is basically one of the main concepts in the CPU. Okay? All the CPUs basically do it. They fetch an instruction from RAM. They decode it. So you fetch the instruction from RAM in the register. The register then, the control unit decodes it. And then the arithmetic, the ALU, executes the instruction. Okay? So you fetch from memory, which is RAM, and then basically you have this thing. Have you ever heard of this program counter? Okay, this comes up a lot in the exam. So a program counter basically keeps track of every instruction, so it increases by 1 every time. So when the CPU's switched on, it's set to 1, 2, so it's just counting every instruction the CPU does. How many instructions will the CPU do per second? Yeah, thousands to millions, yeah. They're basically constantly going. Every nanosecond they're doing probably 1,000. So the program counter keeps track of the memory address of the next instruction to be executed. Okay, so program counter is keeping track of what it has to do. Then when it fetches it, it executes it. CPU decodes the instruction and performs the appropriate operation, whatever that is. And this may involve accessing data from memory or registers, performing arithmetic in the ALU, or issuing commands to other components. Okay, so fetch it in RAM, decode it in the control unit, execute it in the ALU, and then you go back, puts it back into RAM, and then does the same process. It's doing that 1 million times every couple of seconds. It's just constantly doing that fetch, execute cycle, fetch, execute cycle, fetch, execute cycle. Okay, so there's your program counter. So the PC is updated to the point of the next instruction in memory. The cycle starts over again, fetch, and it keeps just continuing until the program is completed or the CPU is halted. CPU uses the program counter to receive the next instruction from memory that needs to execute. The PC holds the memory address of the instruction, and this address is used to fetch the instruction. So again, that came up last year, what is a program counter? And it's just keeping track of what the CPU has to do. What is the next thing the CPU has to do? Where is that stored, the PC, the program counter? Does anyone know where's that stored within the CPU? Not the control unit. Control units find out what it's controlling the operations. Where's everything stored inside the CPU? All these instructions of the next thing it has to do. Yeah, the registers. So the registers has the program counter of what's the next thing it has to do. Does that make sense? Okay, there's a lot of terms in this, and I do understand this is hard, but this is what you need to know for your exam. So again, the program counter is a special register in the processor of a computer. Outline the purpose. So I'll give you 2 minutes to do that. Just 2 minutes. And then the last 5 minutes we'll just fly through the last few slides. Okay. It's in the register. What is the purpose of the program counter? Right, just go through the answer to this. So again, program counter, special register in the processor of a computer. Outline the purpose of the program counter. There's 5 marks, so that whole question there, just that question was worth 5 marks in the short questions. Basically contains the address of, or it contains the address of the instruction to be executed in memory. Okay, so the next instruction to be executed. So the program counter is keeping track of the next instruction to be basically executed, and that is stored then in your register. Registers in the computer is storing the next instructions to be executed by the CPU. Okay, remember they're changing every nanosecond. So again, back to this thing, memory, fetch the instruction, decodes it, sends it then to the registers, which is holding it, and then the arithmetic's getting it and executing it. Okay, it's the same, that same process every time. Fetch, decode it, fetch it into the register, sends it to the control unit, which is telling us what to do, and then the ALU is doing a calculation and then sending it back to the memory unit. What is this memory unit? What's that again? What's the memory? Where's this usually stored? Where's it fetching instructions from? RAM. Yeah, usually RAM. Okay, it is RAM. So again, this is another term that came up in this year's mock. What's the MAR? Memory address register. I'm sure none of you have probably even seen it before. The memory address register is a register in the CPU that holds the memory address of data the CPU needs to access or modify in memory. Okay, that's the definition of it. So the mar down here chats to the program counter. So if it needs to access or modify memory or data, the program counter will access it in mar. There's another one here called memory data register. It's talking to this thing called the CIR, and then the memory data register sends that information into the arithmetic. So it's not just control unit, registers, and arithmetic. You need to know the program counter, the mar, and the memory data register too. Okay, for top marks, that does come up. Okay, just to know them. So the cycle then consists of several stages. So all these here then all come together: the CIR, the PC, the mar, and that would get you full marks. You need to write that out for full marks of the cycle, what the fetch execute cycle is. So the memory address held in the program counter is copied into the mar. The address in the program counter is then incremented, increased by 1 after it fetches it, and the program counter now holds the address to the next instruction to be fetched. The processor sends a signal along the address bus to memory address held in mar. The next instruction is held in that memory address, is sent along the data bus to the memory data register, so that's that MDR down here. It's sent to this. Then that instruction is then copied into the CIR, the current instruction register. The instruction is held in CIR, is decoded and then executed. Results are processed, stored in the A accumulator, and then the cycle returns to the next step. That's copy and pasted from a marking scheme. Okay, that was the detail. I think it was a long question one of the years that asked it in detail, write out the fetch execute cycle. That's copy and pasted. I didn't make that up. That's what they were looking for, their answer. So you need to know mar, program counter, address, all the buses, and then the data register, and right into the accumulator. So it does go in real detail. And there they all are. So what it's basically doing is you're getting the information from these registers, from the RAM, and then it's sent to the control unit and doing arithmetic on it. It's doing some calculations on it, okay, of your data, of all your buses that is sending the information up to them. So explain the cycle of operations that are carried out during the fetch execute cycle. And that's it. And the role of registers. Program counter register contains the address, the memory location. The instruction at the address is copied. The instruction is sent to the current instruction register, the CIR. The program counter increased by 1. The instruction is decoded and executed, and the cycle is repeated. Like you wouldn't, like that was worth 15 marks. If you just say, oh, it's fetched from the control, or it's fetched from memory, it's decoded then by the ALU, and then it's executed. If you said that, you'd probably get 5 marks, 4 marks. You're losing your 10 marks because you don't mention the program counter and you don't mention the current instruction register, okay, and the memory data register. So it's just to make you aware, if you're looking to get that top marks, that's what they're looking for in the marking scheme. Does that make sense, people? I know that is really high level, all that kind of CPU stuff, but that's what they're looking for if you want to get your top marks. Okay, so that's basically me read up. There is one extra thing, the von Neumann architecture of how that works. Again, it's a very popular question of how it works, how the CPU and registers all work in Harvard, and then there's exam questions at the end. Again, ask you to draw that, but that's the CPU. So hopefully from that today, take out the SDLC, section C, how you can be reading from a file. Okay, it's very important, and maybe look over your for loops and stuff. YouTube's great help for that. And then the electronic parts, again, very popular, and definitely the CPU. That fetch execute cycle is nearly guaranteed. It seems to come up nearly every year. Okay, any of you have any questions? Yeah. Yeah, they're in a different section. We might put them all into one section. Is that okay?
Would we get a link sent off?
Do you want me to put up the one from the start again? if you registered, you got emails from when you registered, didn't you? Yeah, you should. We can probably put that email up. If you want, there's my stuff from today. That is the PowerPoint, and it will have the Replit stuff too inside that. That's just today's, all the PowerPoints from today, the 3 sessions. So thanks for listening, and hopefully it was a help.